Welcome everyone. This is the second lecture in our series and the second part to the first chapter. In this lecture we'll be dealing about the remaining part of the chapter 1, which are generation of programming languages and categorization of high-level languages. Let us begin with generation of programming languages. Programming languages have been divided into 5 different types on the basis of power, simplicity and uses. They are first generation programming language or machine level language, second generation programming language also known as assembly level language, third generation programming language also known as procedural language, fourth generation programming language also known as problem oriented language, and finally the fifth generation programming language also known as natural languages. Let us begin with first generation programming language also known as machine level language. These were the earliest used programming language in the history of automation. Programs at this generation are very much close to the hardware or machine because at that time not much research had been done in programming languages. Machine level languages are the only languages that can be understood by hardware without any language translation. It is entirely written in zeros and ones. That means instruction and codes written in this language are entirely made up of combinations of zeros and ones. There is not, however, a single language that is acceptable by every hardware. Because the architecture used in hardware can be different in different machines, the machine language thus understood by the machine varies with the machine. Each type or family of a processor requires its own machine level language. For the same reason, machine level languages are also known as machine dependent or not portable. Meaning machine level language which is readable by machine A may not be readable by machine B simply because the architecture is different. For example, machine level language of machines belonging to ARM architecture is different to the machines belonging to Intel architecture. Therefore, machine level codes of ARM architecture or ARM processors are different than Intel processors. In the first generation programming language, programmers had no options but to write code in machine level language because there were no new or easier programming language available. Machine level programs have the advantage of executing at a faster rate and being more efficient. But writing programs in this programming language is tedious, hard, and time consuming at the same time. Because machine level language which is written in zeros and ones is not directly understood by people, it is also known as low level language. Since machine level programmer must specify every detail or operation that is to be done by the machine at the machine level, the programmer needs to have a detailed knowledge of how the computer works or the processor works. As a result, programmers were fewer in numbers. Also, debugging was a very tough task. As a result, more easier programming languages were sought and developed later in time, but these languages had to be converted ultimately to machine level language for machines to execute them. This is how different generation of programming languages came into existence. Now we are going to talk about second generation programming language, which is also known as assembly level languages. The first step in making the software designing process or software writing process easier was the introduction of the assembly level language because it replaced the instructions which were written in combinations of zeros and ones by simple mnemonic words which could be easily memorized by users or programmers. That is, assembly language uses mnemonic operation codes and symbolic addresses instead of the combination of zeros and ones to do various operations. A mnemonic is an alphabetical abbreviation used as a memory aid. This means a programmer can only remember mnemonic codes instead of long combinations of zeros and ones which are difficult to remember. For example, it is easier to remember the operation ADD instead of, let's say, 111011 for add. And it is easier to remember LOAD load for load operation instead of 01011101. So you can see how programming in assembly level language made it still easier than machine level language to code. But programming in assembly language was still hard because they still required the knowledge of the computer architectures and how things worked. They are still known as low level language because they still require the extensive knowledge of the hardware architecture and how things worked. Although assembly level language represented an obvious improvement over the machine level language, but they still had some difficulties because only those people who knew the architecture very well could program them. And because they were machine level language, they could not be used in other platforms. Now let's talk about the working. Assembly level languages cannot be directly read by machines, and they have to be translated to machine level language by some software, and this kind of software is known as assembler. So the job of assembler is to convert the assembly level language into the machine level language which the machine can understand. When compared to high level language, which is yet to be discussed, these programs are easier to execute, efficient, and take up less memory. The disadvantage as compared to machine level language is that they are slower to execute because they have to be converted to machine level language before execution. So now let's discuss about assembler. So what is an assembler? An assembler is a software or a language translator which converts the codes that are written in assembly level language to machine level language that are made up of zeros and ones which the machine can finally understand. Assembler does this job by converting each source operation to the corresponding instructions in machine level language and converting the symbolic addresses to the corresponding machine addresses. Further, it allocates storage memory and indicates invalid syntax. Only when the assembly level code is converted to machine level language can it be executed by the machine. Now let's talk about third generation programming language, which is also known as procedural language. Third generation programming language marks the beginning of high level programming languages. So the primary objective behind the development of high level languages can be viewed as follows. In the first and second generation programming language, programmers had to have a detailed knowledge of the working platform for which the code was to be written, and this job was very hard and consumed a large amount of time. So programmers wanted to save their time, which was currently being spent on learning the architecture of the hardware instead of writing actual programs. Second, programmers wanted to write programs that could run on all platforms, meaning they wanted to make their programs platform independent. Therefore, they do not have to write the same code over and over again for different processors. So the primary reason behind development of high level languages was to allow programmers to spend more time on writing actual programs than on studying the platform and develop more programs. So finally, third generation programming languages consist of text and mathematical expressions that are used commonly and can be understood by more people than first and second generation programming languages. And they are designed to run on computers with different architectures as well. Most high-level programming languages are considered to be procedural because the program consists of a list of steps to be done by the program or by the computer so as to accomplish a certain task. So basically in third generation programming languages, programs were not only told what to do but how to do it as well. High-level languages, when translated, generate more number of assembly language instructions and even more number of machine level instructions. Similar to assembly level language, a language translator is required by high level languages to convert them to machine level language so that they can be finally understood by the machine. Two types of language translator can be used to do the task. They are compilers and interpreters. Fortran, COBOL and ALGOL are some of the examples of early third generation programming languages. Similarly, some of the very famous third generation programming languages are C, C++, Java. Now let's move on to the fourth generation programming language. The primary objectives behind generation of fourth generation programming languages are as follows. First, increasing the speed of writing programs or developing programs. Second, minimizing user effort to obtain information from computer. Fourth generation programming languages are also known as very high level languages. They are also known as non-procedural language because they allow users to only specify what is to be done by the software and not how it should be done. Consequently, a fourth generation programming language only requires about 1/10 of the program instructions to achieve the same task as was done by previous high-level programming languages. Because they are so much easier to use, they allow non-professionals and common users to develop applications by themselves. They are especially focused on database management systems. 5 types of language tools have been commonly used in this generation of programming languages. They can be discussed under query language, report generators, application generators, decision support systems and financial planning, and some microcomputer application software. Let's talk about query language. Query language, like the queries used in MS Access, allows users to extract information from their databases. Similarly, report generators allow the users to make reports from an already existing database. Let's talk about application generators. It consists of a number of pre-programmed modules which are designed for a specific purposes, and the user can only specify what the program should do. The resulting file is the input to application generator, which determines how to perform these tasks, which then produces necessary instruction for the software program. Fusion, Mark V, Rapid/300, CA Universe are some examples of application generators. Let's talk about decision support system and financial planning. They allow special interactive computer programs and hardware to allow high-level managers to extract data or to bring in data from different databases and generate and analyze these data to produce decisions that they can use. Some microcomputer application software. They can be used to create specialized softwares. They include spreadsheet programs such as Lotus 1, 2 or 3, MS Access, MS Excel, and integrated packages such as Symfony. Now let's talk about 5th generation programming languages or natural languages. Natural languages or the 5th generation programming languages represent the next generation of programming languages in the development of programming languages. In this generation of programming languages, the text used resembles closely to the speech that we use in every day. In fact, one could word a statement in several possible ways with the variations in words and even some slight misspellings and can obtain the same result. These languages are also made to make the computer smarter. Natural languages that are already available for microcomputers are Q&A, Clout, and Savvy Retriever. Other languages are Lisp and Prolog. The use of natural languages touches on expert systems, computerized collections of information on a variety of topics, and the development of AI in various fields. Now we move on to the next topic, which is categorization of high-level languages. High-level programming languages can be categorized into 3 different types. They are procedural programming language, functional programming language, and object-oriented programming language. Let's start by talking about procedural programming language. These are the most common type of high-level languages found today. In this programming language, one or more statements that perform a complete function are grouped together in a program module or called procedures and given a name such as procedure A. If the same operation is required somewhere else in the program, then a simple callback by referring to the name can help us do that. In essence, a procedure is just a mini program, and a large program can be constructed by grouping up such independent or related procedures that performs different tasks. Basically, we view the problem from top to bottom approach and then think about the steps that are required to do the operation and then start writing the codes. C is an excellent example of procedural language. Now let's talk about functional language. What are functional language? Functional programming language allow functions to be processed like a simple mathematical function and allow them to be processed like any other data in the program. This allows a much higher and much rigorous level of program construction. Functional language allow variables to be assigned a value only once. This simplifies programming by reducing the need to be concerned with the exact order of program execution, since a variable does not have to be redeclared or restated each time it is used in a program statement. Many of the key ideas of functional programming language have been used in many modern procedural languages. Some of the examples of functional programming language are Erlang, Haskell, Common Lisp, and Scheme language. Now let's talk about object-oriented language. Object-oriented programming languages are simply the outgrowths of functional programming languages. In object-oriented programming language, the code that is used to operate on data and the data itself are grouped in a closed unit known as object, and all the necessary operation is performed on those objects. This structure allows the object-oriented programming language to model the real-world problems very easily and write very complex programs also. C++, Java are some of the examples of object-oriented programming language. This is the end of the first chapter. So in this lecture we talked about generation of programming language, which could be divided into first generation programming language, which is also known as machine level language. Similarly, second generation programming language, which is also known as assembly level language. Then we talked about third generation programming language, which is also known as procedural languages. The fourth type were fourth generation programming language, also known as problem oriented language. And finally, the fifth, which is known as natural languages. In fourth generation programming language, we studied about 5 basic types of language tools that fall in fourth generation programming language. The first was query language. The second was report generator. The third was application generator. The fourth was decision support systems. And financial planning. The fifth was some microcomputer application software. Then in the next topic we talked about classification of high-level languages, which were divided into procedural language, functional programming language, and object-oriented language. This will be all for the second lecture. Thank you.